Today's lesson is part 2 of Module 1, Topic 1, Lesson 3. We're going to start today with an angle. An angle consists of two different rays that have the same endpoint. Here is our example of an angle. This part right here is the actual angle itself, and this point A is called the vertex. The two sides of our angle are rays. They start at the vertex and they head towards the point near the angle. So this side would be ray AB, and this side down here would be ray AC. There we go. Remember, if you're not going to use the symbol for ray, you do need to write the word. So if I wasn't going to use the symbol, I would have to write the word ray and then put AC. All right, to name an angle, I must use the vertex. So since this is the only angle A in my picture, I could simply call it angle A. Sometimes that is not always the case, and so we must use all three letters. So the rule when we're using all 3 points on the ray is we must put the vertex in the center. So I'm just going to use my color blue for the vertex just to let you know that I have to call it BAC. And one thing that you could add here is you could add the word vertex. That point there has to be the vertex. Or you don't like back, you could call it angle CAB, C-A-B. This is perfectly fine as well because we have that vertex right there in the center. It has to be in the center of the 3 points. Okay, I like to name angles because they're telling me exactly where to look in the picture. This one right here is telling me start at the angle point B, head to the point A, and end at point C. And it's going to show me my angle. Same thing here with CAB, start at C, go to A, end at B. All right, let's take a look at this geometric figure right here, and let's go ahead and name 3 angles. I don't see 3 angles. I only see 2 angles. I see this angle right here, and I see this angle right here. So where is the third angle? That's right. The whole thing together is the third angle. Perfect. Let's go ahead and name these 3 angles. So let's start with that purple one that I missed. I could start at T or I could start at E because H is my vertex, and I could call it THE, angle the. For the blue one, I could call it angle THS, or I could go backwards SHT. And finally, for the pink one, I could name it angle SHE or EHS. Why is angle H not a good name for this angle? Well, angle H is not a good name because there are 3 different angle H's in the picture. There are 3 angle H's. All right, this is going to be our warm-up. So pause the video and see if you can answer these questions based off of this picture, and then unpause the video and let's see if you got them right. All right, I'm sure you got the 4 points. Remember, these are the 4 capital letters next to the dots. Remember, when you are naming separate points, you need to make sure that you separate them somehow. So a comma works great. Name 2 line segments. Any 2 points can create a line segment as long as you use the proper symbol for them. So I could say G and E is a line segment as long as I use this symbol here. And then I could say E and O. There are many more. I could have said G and O. I could have said M and E. I think that's about it. And then, of course, I could go backwards. All right, name three rays. To name three rays, I need an endpoint and I need an arrow. So the only endpoint that makes sense in my mind is point E. I'm going to head point E to this arrow, so EO. I'm going to head point E to this arrow, EM. And I'm going to head point E to this arrow, point G. Now, that is not the only three that there are. You could have used point G to get you two of them, but you would have had to have, well, I guess no, you could have used point G to give you this one, and you could have used point O to give you that one. You could have done that as well, but you still would have to use E and M. But I'm going to go ahead and just use point E because it made the most sense in my mind. Okay, but knowing there are those other two rays as well, GE or GO, and then there's this one, OE or OG. All right, name two angles. I see angle 1 right here and angle 2 right here. So I'm going to go ahead and call angle 1. Let me just put a 1 right there for you. I'm going to go ahead and call it, I can't call it angle E, so I'm going to go ahead and call it MEG. Meg, how cute. And then on the other one side, I'm going to call it, I'm going to say angle 2. I'm going to go ahead and call that one angle MEO. All right, and then name the line in three ways. Well, the line I know has to have the two arrows, so I'm going to use these 3 points to name it in two at a time. Two at a time. So G, E, E, O. I can do better, the EO and GO. And then I'm going to come back and I'm going to put the symbol, because if I don't put the symbol, I'm not talking about the line. And if I don't want to use the symbol, I have to use the word line. All right, today we're going to learn some postulates, 3 separate postulates that are going to allow us to find lengths of segments and angles and lines. Our first postulate is called the segment addition postulate, and it says if B is between A and C, then AB plus BC equals AC. All right, let's grab our highlighters. So notice it's saying AB, this part right here, plus BC, this part right here, is going to equal AC, the whole thing. So part plus part equals the whole. Okay, since you have picked your 3 colors, stick with your 3 colors and use them every time you see a segment like this. Okay, the reverse is true, the converse is true. If BCAB plus BC equals AC, then this means that the picture has to look like B is between A and C. Shh, it's okay, baby. We can go ahead and use our segment addition postulate for a longer segment. So notice here, I have parts PQ, QR, and I have this third segment, RS, that would have to be added to get the whole thing from P to Q, the pink part, plus QR, the blue part, plus RS, the yellow part, is going to add all up to get me from P to S, the beginning to the end. See what this postulate, this rule looks like in geometry. Suppose M is between L and N. Now this statement right here is setting up what the picture looks like. Okay, now notice there is no picture. There's no diagram drawn for you. I don't have to draw you a diagram, but since we're just learning in these first few weeks of geometry, I will try my hardest to provide you with a diagram. So I know there's a line segment. I know I have 3 points on it, M, L, and N, and then M is between L and N. That means this point has to be M, and L's on one side and N's on the other. I can switch them, it's okay. Now they're going to go through and they're going to start telling me how long each part is. But I can look right up above at my postulate and I know that this piece, right, I'm going to take that piece, and I'm going to add to get to it this piece, add to it that piece, and it has to equal the whole part. Okay, so notice my first piece, I highlighted LM. I can come right here, LM, and I can put it right here into my pink highlight, or I could put it right here into my picture, whichever works best for you. Sometimes you see it in the picture instead of it a sentence. My next one is MN. If I look at my picture, I highlighted that in blue. So I could add the 3y right here, the 3y plus 4 here, or I could add it to my picture between the letters M and N. Of course, as I continue to read, and LN is 143. If I look at my picture, I see L is at one end and N at the other. That is my purple. That was not my pencil. There we go. And it goes the whole way. Sometimes it's helpful just to help remind yourself that it goes the whole way. Where's my purple over here? There we go. 143. And now I have set up my equation. This is the geometry. This is the segment addition postulate. Now, you are going to go ahead and solve for y, and you are going to have to give me a numerical answer, some kind of number. Maybe it's 7, I don't know. And then we're going to go ahead and find the lengths of LM and MN. That means we're going to have to plug them back in. All right, let's go ahead and solve this equation. Remember, if it's helpful, draw the line through the equal sign so that you can focus on can you add or not. All right, let me just pick a color here for my Y. I'm going to pick green because I've used pink and blue and purple. So I'm going to go ahead and pick green. I can see that these two are on the same side, okay? I can see that these two y's are on the same side, so maybe I circle them together and I'm going to add them. So 7y plus 3y would give me 10y. I could also take this positive 9 and this positive 4 and combine them together. So 9 plus 4 is going to give me 13. I've done nothing to my 143, so I'm just going to go ahead and copy it. Okay. Remember, the whole reason for me making that Y a green color is to focus my brain over here to the 10 and the 13. I also know that I have to get rid of the one without the green Y first, so I'm going to go to the 13, and since it's positive, I'm going to subtract it to the other side because I always do the opposite, leaving me with 10y on this side, and once I subtract, I get 130 on the other side. Now the green is telling me to get rid of the 10, and since they're side by side, I know that multiplication is hiding there, so to get rid of it, I am going to divide by 10, giving me an answer of y equals 13. I can put that on my answer line, and now I can plug it in to help me figure out the answers for LM and MN. So LM, I'm going to go back and look for the letters L and M. That is the one that I highlighted in pink. This is my pink one. And MN, I can see right next to it, are the ones that I highlighted in blue. Okay, so I'm going to go ahead and I'm going to plug in my answer. It is not a bad idea to show what you plugged into your calculator. Okay, am I going to plug this into my calculator? Yes, I am, because do I know what 7 times 13 is? Not off the top of my head, I do not. So I'm going to go ahead and plug it in my calculator to get an answer of 100. I'm going to do the same thing with MN. 3 times 13 plus 4. My calculator knows that those parentheses are the times, and it'll do it for me for an answer of 43. All right, let's take a look at our next postulate, which is the angle addition postulate. It is very similar. We've just taken our segment and now we've folded it up to create an angle. It says if P is on the interior of angle RST, which it is, then this angle right here, plus the measure of PST, nope, that was supposed to be blue, there we go, PST is equal to the measure of RST. So notice our two pieces are inside now, and they're going to equal the whole thing, okay? Of course, the converse of this is true as well, just like it was. Okay, baby. Excuse my dog, there's a thunderstorm today. All right, let's go ahead and practice. In our example, we know that the measure of angle LKN is 145 degrees. So find the letter L, go to the letter K, and end at the letter L. This is the purple one from up above. So I'm going to go ahead and highlight it in purple. And since the numbers are not here, I'm going to go ahead and do this. I like to go like that, and I'm going to put my 145 down here. Now, sometimes we don't necessarily have to have that, right? We don't have to have that. We could use our equation, right? All right, then it says LKM, L to K to M. That's this piece right here. I'm going to, per my picture up above, per my postulate, I'm going to go ahead and make that pink, and it's going to go right here. And just like when we did the segment addition, I can fill it right into the formula, right? Or I could come and it would look like this in the picture. Okay, if I were to put it in the picture, it would look like this. That probably means that this last one, MKN, is going to be this piece right here. Yep, they match the measure of MKN. So once again, I could put it into the formula, right? Or I could put it into the picture. I want to go ahead today and show you both, just simply because sometimes the information is given to you in a picture versus in a sentence like we have here in our example. All right, we do need to find the measures of LKM. And if I just take the time right now, I can figure out what color that is. Okay, sir. LKM, that's the pink one. And MKN, that's the blue one. But to be able to find those two, I am going to go ahead and have to solve this equation. So let's go ahead and do that. All right, drawing my line. And then once again, I can use my color to help me decide if I combine these two or if I subtract or if I eliminate and move to the other side. So they are together on the same side. So I could go ahead and do 2x plus 4x, that's 6x. I could also take this positive 10 and subtract 3 from it, giving me plus 7 on this side. Remember, the purpose of the color for x is to help your brain to say, I have to get rid of the 6 and I have to get rid of the 7, but the 7 goes first because it doesn't have the green x with it. So I'm going to go ahead and subtract because it is a positive 7. Squeezing my 6x over, doing my subtraction, I get 138. Now the green X is telling me to get rid of the 6 by dividing, because whenever, remember, a number is next to a variable like that, we have multiplication, so we must divide, and our answer is 23 for X. But remember, we did have to go back and we did have to plug them in. So for the measure of angle LKM, poor baby, I'm going to do 2 times 23 plus 10. That's what I'm going to plop into my calculator, and I get 56 degrees. And then for the measure of angle MKN, I'm going to go ahead and pop it into the blue one, which is 4 times 23 minus 3, and I get 89. These would be considered my answer. Okay. All right. Our last postulate today that we're going to talk about is called the linear pair postulate. A linear pair of angles is going to make a straight line. Linear line. So notice we have this ray sticking up, creating 2 angles that make a line, creating a linear pair. A linear pair is 2 adjacent. I do apologize. Adjacent just means that we are right next to each other. We can touch each other. Go ahead and ignore that. Angles whose non-common sides form opposite rays. Linear pairs are supplementary. Now there's a word we haven't heard probably since 7th or 8th grade. If you recall, supplementary means that we add to 180 degrees. We add to 180 degrees. So if we take a look at our 2 angles here, we have angle 1 and we have angle 2 because we don't have points on them. All I know is that angle 1 plus angle 2 is going to give me 180 degrees. Why do I know this? Because they make a straight line. This is why the linear pair postulate works. So let's take a look here at our 2 examples. We could simply solve this equation by doing the math like so. Okay? Notice that it's a one-step equation. We just have a plus. So all we have to do is subtract the 112 from the 180, and we get our answer for X. Okay, we get our answer for X. Let's go ahead and take a look at this example. 2 angles form a linear pair. The measure of one angle is 3 times the measure of the other. So since we don't know what the angles are, I'm going to go ahead and call them angle 1 and angle 2. And since I know that they are a linear pair, I know that this is the formula to figure out what these angles equal. Okay? Angle 1 plus angle 2 equals 180 degrees. I'm using angle 1 and angle 2 as their names because the problem itself did not name them like our previous examples did. So it's okay to call them angle 1 and angle 2 or angle A and angle B. You could use whichever nomenclature you'd like. Okay? Now I'm going to go ahead and figure out what the sentences said, what our problems told me about angle 1 and angle 2. It said right here, starting right here, the measure of one angle is 3 times the measure of the other. So one angle is X and the other one is 3 times it. So I'm going to go ahead and call it 3X. Now I can go ahead and plug these into my formula, which is the linear pair postulate, and I can solve this for X. There we go. Let me go ahead and zoom in here. Once again, my X's are on the same side, right? I can use my circling to help me to determine that. This X has a 1 in front of it, meaning I have 4X on this side. Notice also that I dropped the degree symbol, okay? This is part of the postulate. It says angle 1 and angle 2 add to 180 degrees. But here as we do the math, we're going to drop the degree symbol because it's not doing anything to our number 180, okay? Our x is still by itself. There's no plus or minus to get rid of first, so we're simply going to divide by 4, giving us an answer of x equals 45. If I had to go back and say, oh yes, find the measures of each angle, so angle 1 is going to be x, so it's 45 degrees. Angle 2 is going to be 3 times 45, so it's going to be 135 degrees. These would be considered our answers right here. There we go. I hope this helps, Tigers.